The content is reviewed by a professional engineer and researchers to ensure factual accuracy. High above us, there is a barren, rocky piece of land, almost as wide as Australia. For more than 4 billion years, it has silently witnessed every life form, every species, and the whole planetary evolution on Earth. It has no life on its surface, and yet without it, we would not exist in the way we do. This is the story of Earth's firstborn child, named the Moon. Not just how it was born, but how it continues to shape the Earth itself. Approximately 4 billion years ago, the solar system was young, aggressive, and in its very hot-headed phase. Planets were not peaceful spheres. They were molten, unstable, and prone to collisions with one another. So was the Earth, young, hot, and still maturing its crust. And then, a protoplanet, roughly the size of Mars, wandered into the Earth's orbit. Today, scientists call it Theia, named after a Greek mythical goddess who mothers the moon. Earth and Theia felt immense gravity for each other, and as per the universal law of attraction, they too danced impatiently to become singular. And they finally met, sending the shock waves of their energetic union across the whole neighborhood. Rock vaporized, debris was blasted into orbit. But instead of drifting away into space, that debris began to gather and revolve around the Earth. The great Theia sacrificed herself to bring a new terrestrial being in this universe. A helpful child for Earth and an eternal reminder of their love. This very child reshaped our lifeless planet, kicking in the next planetary phase, or the fate as called by many. 400,000 kilometers away, our silent companion moves, accompanying the Earth along its trajectory around the Sun. The Moon does not wander. It falls around Earth, again and again, locked tightly by the gravity. Once every 27.3 days, it completes a journey. And in that slow-motion dance, it keeps one face turned toward us at all times, because it rotates at exactly the same rate as it orbits Earth, also known as tidal locking. For Earth, this quiet companionship changes everything. Its gravity reaches across the space and pulls at our oceans. Tides rise, tides fall, coastlines breathe. Those tides stir the seas, circulate nutrients, support marine life. Perhaps it even helped the first life forms begin in these oceans. The Moon steadies our planet too. Without it, Earth would wobble wildly. Seasons would swing to extremes. Climate would turn chaotic. Instead, our tilt stays gentle. Our seasons stay reliable, and civilizations thrive under stable skies. But the Moon itself seems selfless and dead. Its surface is scarred by millions of asteroidal impacts. Due to its smaller size, it has almost no atmosphere to protect it. No wind erases its history. Every crater is a record. Every mark is eternal. When astronauts from NASA stepped onto its surface, they were walking on a geological archive. Footprints placed in 1969 are still there today. Untouched, unmoved, preserved in vacuum for millions of years to come. Today, the Moon is no longer a mere distant ornament in Earth's sky. it is once again a strategic destination. Through the Artemis program, humanity is returning to the lunar surface, not for symbolic visits, but for sustained presence. Data from missions such as LRO and impact analyses have confirmed the presence of frozen water near the lunar poles. That water can be converted into drinking supplies, breathable oxygen, and even rocket fuel. The Moon also preserves an undisturbed geological record of the early solar system, material that has remained largely unchanged for over 4 billion years. Studying it could refine our understanding of planetary formation and the origins of Earth's chemistry. Strategically, the Moon offers another advantage. Its reduced gravity makes it an ideal staging ground for deep space missions, including future expeditions to Mars. The next era of lunar exploration is not about revisiting history alone. It is about establishing humanity's first operational base beyond Earth. Eternity is a beautiful lie. The Moon is slowly drifting away from Earth because of tidal forces. Earth's rotation creates tidal bulges in the oceans, and because Earth spins faster than the Moon orbits, those bulges are pulled slightly ahead of the Moon. The Moon's gravity then pulls back on those bulges, stealing a tiny amount of Earth's rotational energy every time. That transferred energy pushes the Moon into a higher orbit. As a result, the Moon is moving away at an average rate of about 3.8 centimeters per year, roughly the speed at which your fingernails grow. Billions of years from now, the Moon will continue drifting away. Tides will weaken. Days on Earth will grow longer and longer. And eventually, long after humanity is gone, the Moon will still orbit a dying sun. Silent, unchanged, a witness to everything that ever happened here. Stay grateful and curious. If this video sparked your interest, like, subscribe, and hit the bell for more science explained simply.